Okay, so this lesson we're talking about the scalar product. Now, I attached a video that's not by me, it's by somebody else, but it's a really good explanation of what the scalar product is. So really, if you haven't watched that, make sure you go back and watch that because it makes it really, really clear. But I'm just going to go through it as well, just to make sure I've covered everything with you as well. So what is the scalar product? Well, it's basically when you multiply two vectors together. You see this equation in your equation sheet for the vectors a and b. The scalar product is defined as a dot b times a dot b equals magnitude of a times magnitude of b cos theta, where the angle theta is between a and b, and it's between 0 and 180 degrees. And there's a few things to remember. So vectors must point away from the vertex, and the scalar product is not itself a vector, it's actually a scalar. So it's just a multiply. It's just like a multiplying factor. Okay, so if you watched the video before, you should have like a really good intuition about how this works. But I'm just going to go ahead and do a little example just to show how we will have to solve these type of questions. Okay, so here we're told to find a dot b, where the magnitude of a is 5 and the magnitude of b is 7. So a dot b equals magnitude of a, magnitude of b, cos theta. So what's going to happen here? Well, 5 times 7 cos, and these are pointing away from each other, so you can just put in cos 45. It's pretty straightforward. So 5 times 7 is 35. What's cos 45? Well, some of you might have memorized this, but if you haven't, you can always just think about your triangles. This is 1, 1, root 2, it's 45 here. And so okay, so it's cos 45, so cos SOH CAH, it's adjacent over hypotenuse, so it's times 1 over root 2, but you don't often see it like this, because if you times it by root 2 over root 2, you get root 2 over 2, which is the way that they like to have it written in the exam. So this gives you your final answer of 35 root 2 over 2. So it's pretty straightforward. This example here looks very similar to before, except actually there's only one subtle difference. Let's see if you spot it. So as before we said, find a dot b, where a is 5, the magnitude of a is 5, the magnitude of b is 7. Okay, so this is going to be a dot b equals magnitude of a, magnitude of b, cos theta. So again, it's going to be 35 from before, because that's 5 times 7, and then it's going to be cos what? Well, here you notice that this arrow is actually pointing towards the tail of the other one, so they're not pointing away from each other. So this equation won't hold true, because it's only true for angles between 0 and 180. If you think about rotating the angles to see how they line up with each other, then it's just not going to work here. So what are we going to have to do? Well, we can bring this vector here along to here, so they are tail to tail. So that's exactly the same here. So now we need to think about what this angle in here is. Well, we know that this angle is 45 degrees, and from similar angles, you should know that all angles in a line add up to 180. So we know that this is going to be 135 degrees. Okay, so now that we know that it's 135 degrees, how else does this help us? Okay, well, where's 185 degrees going to land in our cast diagram? C, A, S, t. So 0 to 90 is here, 180, 270, 360. Well, it's going to land in here, isn't it? It's going to land in there. 130 is in this section. But because this is a cos, we know that that's actually going to be negative for this in here. It's going to be a negative value for cos, because cos is only positive here and here. Okay, so we know that it's going to be negative cos. And then we want to take the acute angle, which was 45 degrees, and stick this in here, 45 degrees. And again, it's going to be exactly the same as in the previous question. It's going to be 35, but instead of minus, it's going to be, and then you're going to have a minus root 2 over 2. So it's the same as before. Except that you had to make sure that the angles, the two vectors are pointing away from each other. This is really important because this is quite a sneaky way to confuse people. So just make sure you keep an eye out for this.